some of you did it this way. So this system equals to this one. Oh, do you want to mean that, well, this is the negative direction, so you put the minus sign over here. Okay, it is confusing to me. You get the point? This is clockwise, so clockwise is negative. If you have the arrow, basically you just should keep the arrow and the magnitude. If you want to mean it this way, then okay, don't put it like this and then backward like this. Okay, but if you put it like this, then it will be equivalent to negative, to this negative direction turns out to be positive. So I'm kind of confused because sometimes the sign convention or well, you end up with the wrong sign. Okay, and then I track back to here and then okay, what is going on in here? Okay, this is the first point. The second point, I can see that you still collaborate. Okay, I would like to make it fully independent. I mean, really fully independent. So if you work on these sort of things individually, you will have two things at a time: imagination, one thing, and then also the knowledge. If you work with your friends, and maybe there will be one friend who get okay everything and then ready to go forward. So when you are working with your friends, you will have some sort of, let's say, skeleton for you to climb up. All right, so you are not developing your own skeleton. Okay, and then you might feel like, oh, okay, I look at my friends and then, oh, I get it, yeah, I understand it. But yes, you have the knowledge part, but the imagination part, or the way you struggle to solve problem, to tackle the problem, you will not have that part grown up with you. Okay, but your friends only, the first guy who prepare, who develop the solution has that idea. Okay, you need that also. That will be necessary for, well, to do the exam problem and also to be a great engineer or researcher. Okay, if you want to call it that way. All right, so quite important. I still can see the trace that, okay, yeah, you work together. No, let's not work together. Okay, try to struggle by yourself. And then at the moment when you can come up with the way out by yourself, all right, you feel like so happy, you're so proud. Okay, you might be obsessed with one problem, taking shower, you think of it, waking up in the morning, you think of it, but it's gonna take a while. But at the moment that you just get through it, okay, that's a very good feeling. Okay, it is quite important. You might not see that it is so important to struggle it out by yourself, but I really mean it. Okay, that would be the difference between the guy who developed the first solution and the guy who looked into the first solution. Okay, and then I would go this way. Okay, you're blocking your imagination. You will not see any way out, but just this way that is given to you. Okay, it is like you. Well, it's like you. One guy read the Harry Potters from the books, okay, and then things like not just like you watch from the movie. Okay, you watch from a movie, okay, you can see Harry Potter looks like this, okay, it has to be like this, but when you read from the book or from that description, you come up with the different sort of picture, imaginations. Things can fly more than in the movies, okay, even with the great CG. Right, so okay, let's keep it that way. Right, I great. I know that, okay, how things done. So try to do it independently. Okay, so right now you have reaction to counterbalance with this uniformly distributed load, and then you get this load. Okay, compute the R will be equals to F multiplied by L, right? Okay, there is no force at this tip, okay? And then this system is added up with another system. This one, you're gonna produce the displacement to this direction. Okay, what is this displacement? It's supposed to be an easy problem if it is in the exam. Should it? How do you calculate this one? This delta, okay, F. So, calculate this one. Any idea? How is the strain distribution within this one? And if you think a while, for this one you have the force that will push back, okay? This will counterbalance by this force, okay? Okay, this one counterbalanced by this one, producing the delta P, okay? So you have one force pushing to the left, one force that is pulling to the right, okay? These two adds up. You better get a zero displacement. That's the condition that you need to satisfy in order to come back to this original figure. And then once you satisfy this condition, you can find out the magnitude of R, magnitude of P, and this P, and then you can find the fixed end reaction. Okay, but how to come up with this and this? This one is pretty easy, right? Because this one is going to be equals to what? You have a force P, okay, divided by EA. You come up with stress, right? You multiply by L. This is a strain, not stress. P over A, you get stress. Divide by E, you get strain. Strain to L, you get displacement. Alright, that's it. As well, this one. For this one, your force is not uniform. Alright, if you take a cut over here, you get force equals to FL. And then your force distribution will be reducing along the length. Alright, so along the X, well, it is decreasing. So if I plot out your force distribution, if I take a cut in your material, in your bar at any point, alright, so this point, X equals to L, this is X equals to 0. Okay, this is the force, okay, internal force, okay, so start with FL, right? Over here at the support, you have FL, this is balanced by R, so you cut just right over here, you get FL. And then once you go far away, okay, when you are far away, when you are here, okay, maybe at this point, X, okay, from the support, what will be the force in here? Well, you take the cut, you have this distributed load acting on this L minus X, right? So you will end up with the function of this one at any point being the what? L minus X multiplied by F. So as the X increases, okay, then the force in your cross section will be reduced all the way down to 0 when you approach to the L, X equals to L. Alright? Yeah. So this is just simply a linear function. Okay. Now, your internal force diagram looks just like this. Once you know internal force diagram, what you can come up with next? Internal force, you can come up with stress. From stress, you get strain, okay? For this case, your life is still very easy because your EA is constant, right? So your EA constant, then your strain diagram, strain distribution is gonna look like L minus X multiplied by F all divided by E and A. Okay, so this axis has become the strain versus the X. Knowing a strain like this, then you can calculate the displacement. Okay, from this point I drop you in the middle of the Bay of Thailand. Will you swim back to the shoreline? Can you? At this point? Come on. If this is really an exam problem, how do you swim back to the shoreline? They just kick you out of the plane.